Good day to every one of you. I'm so glad that you're able to join me in this event. No? So without further ado, we'll start the presentation. So kita naman ba yung PowerPoint?
Yes, sir.
Okay. So we'll start now. Again, they have introduced me, but let me introduce myself again. So my name is Kristum De Guzman. I'm a fifth-year computer engineering student at Mapúa University, and I am an Arduino hobbyist. I may not be professional, but I've done a lot of freelance projects involving Arduino for many years, so I've gained enough experience so that I'll be able to share my knowledge with you. Other than that, there's not much to say other than I'm your Mapuan schoolmate. Okay, so this will be the agenda for today, no? So first is again I'll introduce you to what is an Arduino. Then we'll discuss what can we do with Arduino. Then how do we get started with Arduino, no? And I'll show you how the board works, the board itself. Then we'll create a simple program. We'll discuss simple programming for the Arduino. There's no need to be, you don't need a deep background for to get started with programming, and some additional information regarding Arduino. So let's start with knowing what is Arduino. Again, this event is for those who are interested to start making projects with using the Arduino. So if you're a beginner or hobbyist, I hope I can give you knowledge, an additional knowledge about the Arduinos. Okay, so know what is Arduino. So Arduino is an open source electronic platform. So it's a platform, no? It's both a hardware and a software. So the hardware part is the Arduino board itself. Then the software part is the Arduino IDE. That's where you create the program for the Arduino. So Arduino was made to be a simple hardware prototyping tool, no? So it was born at the Ivrea Interaction Design Institute in 2004 as an easy tool for students without background in electronics and programming, no? So it is used by amateur, hobbyists, and even professionals. So they can make projects of different scales. So they can make a small scale of some future projects that they can make a larger scale of. So here, this is the predecessor of the Arduino. So the Arduino we know today is based from the Wiring IDE, an open source electronics prototyping platform. And here is the very first Arduino that is based on the Atmega chip 168. And as you can see, it uses an old connector, serial connector, the RS232. If you've had Cisco classes back then, you probably know what an RS232 is. So moving on. So what can we do with Arduino? No? So as I've said, it's an electronic, it is a prototyping platform. No? So there's actually a lot of things we can do with Arduino. Here are some of them. So we can make wearables, IoT devices, we can make automations and robotics. So as wearables, Arduino is there are smaller form factors of Arduino. So we can make wearables like an ECG, tracker, a fitness tracker, and you can even make your very own pet GPS tracker, no? To track your pet when they are heading outdoors. Then they can send you location data and that kind of stuff. Moving on, Arduino can also be used as IoT device. You can make a remote weather station, no? You can hook them up to your house, add some relay, so you can make a smart home that knows that when you are leaving and that kind of stuff. So it can automatically turn off your lights and that. Also, Arduino can be used for automation. Again, like the home automation that closes your lights, you can make your very own pet feeder, and you can make an automated irrigation system that is based on moisture of the soil and that kind of stuff, other factors that can affect the growth of a plant. Then robotics. Arduino can be used for driving motors, moving point to point, and any actuators. No, so is one of the famous things you can do with a microcontroller is the 3D printer. No, so and here are the examples. Here we have uh, a robotic arm, and I think this is a robot that can detect whenever it is colliding with something. Okay, no? So, syempre, puro picture lang yan. So, today I'll be showing you some quick project demo that I make for this presentation. So, I made a automatic alcohol dispenser in this time of age. No, it's although we can use the foot pump this alcohol dispenser. I wondered if we can make it automated that we won't need other than placing our hand right in front of the device. And for that, I'll just switch camera real quick. Hello, can you see the camera, guys?
Yes, sir.
Okay. So here, this is the prototype I made. I know it's kind of messy, but what it does is it detects your hand. When you place that over the range where it is detected, it will drive the motor pump inside and pump some small amount of alcohol into your hands. So this is the I use IR sensor for the detection of for proximity, and this is the Arduino board behind here. I know I could have done it cleaner, but this was just a quick project that I made. So yeah, I added an LED as an indicator. No? So what it does is it just release small amount of liquid so that you won't have to touch anything or do an additional movement for to sanitize yourself, no? So this is a pretty neat idea, and it didn't really cost much. Arduino has become a lot cheaper these days. So instead of buying you can, I think you can buy automatic alcohol dispenser, no? But wouldn't it be fun if you make something on your own? Doing this won't really cost you much. These sensors won't even be greater than 100 pesos, and the Arduino board you can buy for less than 200. No, the price has gone down over the years, so that you can really get started easily, no, and it's more accessible na. So let me just return to the presentation. So that's one of the neat things that you can do with the Arduino, no? Then moving on. And so going back. So those are some of the quick projects you can do with Arduino. It's fun, and while doing so, you can learn a lot of things about how things does work, no? And I think that's really good, especially for us engineers. Okay, so now how do we get started? So this will be just a step-by-step procedure on how to use the Arduino platform and board. So if you have Arduino there on your own, or you have access, so you can follow these steps if you want to get started, no? So these are the only things that you'll need: a computer, the Arduino board here, then a USB cable. That some Arduino includes the USB cable, so most commonly used is a Type B, the one you use for printer or printer cable. Okay, so installing the Arduino IDE, it's easy. You can easily download it at their website. They'll ask you for donation, although it's a open source platform, so you can opt to donate or no. So you can download either the XA installer or the zip file. So using the XA installer, it's a clicking simulator. You just open it, then agree, next, next, next. I would suggest that you do this because it includes everything. So you wouldn't need to install other things. Like it already includes the USB driver for the Arduino. Then next, then you'll have something, and you'll have your Arduino installed on your computer easily. So using the zip file, you'll have to download it, then you'll extract it. Right there, you can already use it, but here's the catch. If you don't have the Arduino IDE, your computer probably won't recognize this as an Arduino board. So for you to install the driver, go to the drivers folder, then find the driver installer here. If you're using a 64-bit operating system, open the AMD 64XA file, or if you're using a 32-bit base system, use an x86, no? So again, it's just a simple next, 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 then you'll have your Arduino IDE installed. Once you open your Arduino IDE, you'll get with something like this. So this is an empty sketch. No, this is how your Arduino should look like when you open it. Okay, so connecting your Arduino board to your PC. Again, you use your USB cable included to your board. If you properly install the drivers, no, so it will automatically detect it. You should in your Arduino IDE under tools, then under port, it will show the list of the COM ports that are available, and usually the Arduino board that is recognized will have the Arduino/Genuino Uno label. So you select that. Then to test whether it's working, no, under file, then you have your pre-installed examples there. Under basics, then we'll upload a simple Blink program to the board. So we'll have something like this, no. Once this appeared, just click the upload the pre-made code or the example code. The upload button is fine. Next to that, checks the here. Right next to the check icon, this one is the upload button. No. Once it started, it will write something in the status bar here. Then once it finished uploading, it will show the done uploading. If it had errors, it will show what kind of errors there will be. Yeah, this once you upload it successfully, you'll have something like this: an Arduino board that blinks every second, because that's what we uploaded. So far so good, no? We learned that it's easy to connect and install an Arduino. So let's talk about the Arduino board. So again, this is the first Arduino board. It is based on the Atmega 168 8-bit processor, no? So it's kind of similar to how it looks today. So it has the linear regulators, the crystal oscillators, and some capacitors of some values. So here are the examples of mainstream Arduino boards. So we have here is the Arduino Uno, or this standard is based from the Atmega 328 or 328P chip. Then this is the Arduino Mega. No? This is better suited when your project involves CNC machinery because it provides a lot of pins compared to the Arduino Uno. Then if you want to go something smaller scale, you can use the Arduino Nano or the Pro Micro. Uh, the Arduino Nano is a smaller version based from the same chip. It is an Atmega 328P, while the Arduino Pro Micro is based from the Atmega 32U4. So what it does is sometimes it doesn't come with a USB port. So sometimes you'll have to need a FTDI board to upload the code to the Arduino Pro Micro. So moving on, again, it is the Arduino Uno is based from the Mega 328P chip, 8-bit microcontroller. It has the power source includes the DC barrel jack, or you can power it through the USB. Take note that the DC barrel jack can only take 7 to 12 volts. Even at 12 volts, you can feel the voltage regulators heating up. So I suggest you just power it through USB and use external powers for the sensors and other modules. So we'll discuss about the pins, although we'll skip some pins that aren't usually used, such as this ARF, IRF, and reset. We don't use reset because there's actually already a reset button here if you need one. But if you need something, if you need to reset it in a longer or externally, you can also do that as well. Okay, so in the power, the Arduino board has a 5 volt and 3.3 volt rail. These are regulated rails. So you can power other modules using those rails. Although if you start hooking up a lot more modules, you can see it won't have enough power, no? And sometimes other modules won't work correctly because it's not being supplied with enough power. So I suggest that you use other supply or source. Then this Vin is for voltage input. This is the same with this. So it only accepts 7 to 12 volts, but also you can power it through the 5 volt rail, although I don't recommend it unless you have a regulated 5 volts. Okay, moving on to the digital pins. So overall, there are 14 digital pins. They're general purpose. They can use for input and output. And out of those 14 pins, 6 of which are PWM output pins that provides an 8-bit PMW resolution output using analog write function. The PWM pins can be identified using you can find the labeling the pin labels that has tilde. Those are PWM pins. Then TX and RX pin. They are used to receive and transmit TTL serial data. So you can use an Arduino board. You can hook a GPS module there. It will use the TX and RX pins to communicate with the GPS module or a GSM module. Okay, then the analog pins. So analog pins can actually be used also as a digital pin. although the difference is that it has an analog to digital conversion for input. So it has a 10-bit resolution. So it's not, if you want some precision, you should opt for a higher resolution, bit resolution for the ADC, but it's good enough for many things. So when you connect, example, a potentiometer, you use the analog pins. Okay, we're actually going quite fast. So creating a program. So we'll be discussing some small part programming here. Though if you have background with programming, you can easily follow this. No? So continuing, Arduino is actually based from C or C++ convention and dialect. So if you've already if you've done programming in C++ or C, then programming in Arduino won't be that hard unless you started with Python. Although you can understand it, I think you'll have to adjust more. So it uses an .ino file. Arduino can have different libraries that you can create or you can just download off the internet. Of course, the IDE has its own built-in functions, and also the users are able to create their own function. We'll talk about that later. Okay. So declaring variables. So unlike in, I don't know, Python, you'll need to declare the variables data type here. So here are the commonly used data types. So a variable is declared by declaring the data type followed by its name. The naming convention is that anything you can name your variable in what do you call that? You can name your variable in any way, so long as that it doesn't start with numerical numbers and it doesn't contain any white space. So these are the data types. We have bool for true or false. It's just 1 bit. Then a byte that has values from 0 to 255. It doesn't go below negative. Then we have here for char for character. Then float for floating point numbers. You should use this when you're dealing with decimal numbers, no? Then if you're dealing with a higher value, you should use the double because this double floating point numbers. A float only has 32 bits while double has 64, hence double. Then string is actually a subclass, though if you're going to write string, you should just use this string instead of char. Then void is actually only used for function declaration. Void means that you'll have no return information. No? So declaring variables, there are some scopes. So there are global variables that can be seen all throughout the code. Then we have our local variables that can only be used where it was declared. So to declare a global variable, dun sa root, pinaka-root ng code, outside of the functions, you declare it there. Then you can use it on the other part of the code. While this one is declared only as a local variable, this variable can only be used within this void loop. While this var1 can be used in void setup and in void loop. Okay, so functions. So function is used for controlling the Arduino and performing certain actions and calculations. So there are built-in functions that are ready to use in the software. Then there are user-defined functions that are created to perform a more specified functions when you have a certain input and you want to have some certain action or output. No? So these are some of the commonly used built-in function. No? So digital read. So this is used for reading the values inside the digital pin. It's either high or low, or meaning that when it's high, it means it's receiving voltage, a 5 volt voltage. Then if it's on low, meaning it's connected to a ground. So use digital read, then input the pin value. It's either 0 to 13. Or if you're using the analog, it's either A0 to A5. Then digital write. So it either writes high or low value on the pin. No? So all of these can output 5 volts. No? It's either ground for low and high. Typo pala ako. So it's used by writing the function digital write, then parentheses, the pin, the number of pin, the pin that you want to fiddle with, then the value if it's high or low. Then this one is also important, this pin mode. No? When using Arduino pins, you'll have first to declare whether if it's used for input or output. By default, all of the digital pins can be used as input without even declaring using the pin mode. Although I think it's a good practice to declare it so you won't forget it, or what pins you use for input and that kind of stuff. So it configures the declared pin mode, either input, input pull up, or output. So anong itong input pull up, no? Medyo iba yan. So ang input pull up is used sometimes when you're using the digital pin as an input, if it doesn't have any pull up or pull down resistor, it will have a state also known as a floating state. It's unsure whether it's high or low, so there's higher chance that your program will not work as expected. No. Then next function is the analog read. So analog read is used for the analog pins. No. So it's either A0 to A5. It can read value 0 to 1023 kasi nga it only has 10-bit resolution. So analog write, you use this for PWM pins, although you can also use it for non-PWM pins. But what will happen is that it will just have an on-off cycle. So anything that is not 0 or 255, it will not work on a non-PWM pin. So these are the analog PWM pins are used mostly for motors or servos that requires PWM signal. Then delay value. So it creates a short delay that is in milliseconds, no? So ayun nga yung parang animation na ginawa yung action na ginawa natin kanina, which is yung simple blink. We create a 1-second delay for every other blink cycle, no? Although if you're using an Arduino for timekeeping, I won't trust using delay function or even its own timekeeping function. You better off using an RTC module or a real-time clock, because what do you call that? As it goes longer, the timing won't be the same, and there will be some amount of offset with your time. So I wouldn't recommend this for timekeeping, but it's good for some delays whenever action is performed. No? Para di naman gahol masyado yung Arduino board. Then serial. So serial is used for communication between Arduino and a computer. You can actually connect a Arduino and control it using your computer. You can either use Java or other platform as long as you uh, access the serial. Though most of the times I just use serial because Arduino doesn't have its own debugger, or you cannot do step by step, or you don't have breakpoints using Arduino. So I use serial for displaying values and that kind of stuff. So this is the sketch structure. Again, kanina yung nakita nyo, once you open the Arduino, it doesn't contain anything. It only has the void and loop. Those are the default sketch. Your program won't run without those. You're stuck with that. So here is the void setup. It is used for initializing pins for this. Everything you put inside this will run on startup. So once you open an Arduino board, it will automatically run all of the line of codes that you input here. So this is also where you declare your pin modes for input and output. And if you need other initializations, you also put those codes here. While here in void loop, this function, this is where the block of code here is run indefinitely until the power is cut. No? So microcontrollers are used for mostly for repeated operation or for something it was programmed. No? It cannot do anything outside of that. Okay, so there are also user-defined functions. So it can be created to perform specific operations and actions. So it is you can declare function using again the data type followed by the function name. Noted that data types other than void must have a return value. I'll show you that later, no? Yan. This is defined function. It's this one. This is addition. There's some type of it. Imagine they're the same. So I created a user-defined function addition that accepts two values, integer a and b, then will return the sum of the a and b to whenever it's called. No? So you cannot use it. You'll have error if uh, you didn't input any of the required parameters. So here are again the parameters used to pass the arguments onto the function, and here is the part where you call your function. So here you call the function addition, then you input your arguments, let's say 6 and 9. So it calls the function addition, and you insert the value of 6 and 9 to perform addition or the action of the addition function. No? So the value will be saved or returned to the variable sum. So again, as I've said earlier, I use serial to display data readings from analog. It can help check values from the variables and can also be used for debugging. While serial communication is primarily used to connect Arduino to other devices and PC, we can utilize the simple output checking or reading whenever you use your Arduino. Because you may know that it's receiving data, but you don't know what that data is. So you can use serial to log it. So here are the commands for using the serial. So this serial that begin, you put that in your setup section of the sketch. So serial that begin, then the baud rate. So the baud rate is the rate that the information is being transferred in bits per minute. There are common baud rates, no? Di siya pwedeng mag-iba. Although ang commonly used na baud rate is 9600. It's used for simple stuff where speed isn't critical, no? Then we use the serial.print, then var, or pwede kang mag-input ng string using the quote. So, ano pinagkaiba nila dito ni serial.println? Si serial.println is, it ends on a new line. So, after niya is maggagawa lang siya niyang bagong line. If you use print bar, it will just append the former output, no? Pag ganun siya. Tapos pag ganun yung print line. Then serial.read string is whenever you're passing data from the serial monitor. So to access the serial monitor, you can just click the serial monitor button here, or you can just use the keyboard shortcut Control-Shift-M. Also make sure that you've selected the proper COM port, no? So ayun yung kaninang ginawa natin, yung sinelect yung COM port ng Arduino. So once open, it will have something like this. As you can see here, there are some buttons here. This is used to select the baud rate. So kung ano yung dineclare mong baud rate, dun mo syempre ilalagay yung serial monitor mo, or else you'll be thrown with gibberish data or you won't see the output at all. So modifying the previous code will have something like this. Again, we declare the serial begin here on the void setup. Then we create a serial print line so that it outputs the value of sum, the variable sum, every 10 seconds. So we put a delay there so that it won't go so fast, no? Once we've uploaded it and open the serial monitor, we'll have something like this. 6 plus 9 is 15. Okay, so here are some stuff, conditional statement, no? And flow control logics. So most commonly used, the if, else, while, and for. And these are this control flow uses the logical operators. This one is used for equal. This one is greater than, less than, greater than or equal, less than or equal, and not equal. So conditional statement will start with if. So the statement if is used when you want to run a block of code when condition is met. Naalala ko yung isang meme na yung inutusan siya ng asawa niya na bumili ng gatas. Tapos pag nakakita daw siya ng itlog, bumili daw siya ng 1 dosena. So ginawa nung asawa niya, pag uwi, may dalang 1 dosenang gatas. It's because yung condition doon is kapag nakita siya ng itlog. So it's just a simple true or false. Then we'll run that line of codes, no? Then we use if else if you want to run another block of program when a condition is not met, or you can say it's a default action, no? When none of the conditions are met. Then nested if else. So you can actually daisy chain them and have a multiple alternatives or different conditions, no? So here are some examples. So again, we declare a variable val which contains a value of 3. If we just use the if, we can check here if the value of val is greater than 0. If it is, then it will output val is greater than 3, which it did met. The condition was met. So using if else, this is what will happen, no? If value is if the condition is if val is less than 0, then it will output val is less than 0. Else, it will output that the val is 0. So using the else, there's no condition, so it doesn't have another condition unless, unlike the if if and else if. So here using again the val that has value of 3. If this one, there are two conditions na, no? So these are the alternatives. Unlike this one is a condition and this one is not an alternative. This one is a default action. So you can do an nested if else a lot of times. Then you can also do an if else and you have a default function when none of those conditions were met. No? So example here, if val is equals to, which is it's not, then it will check if the val is equals to not to 1, which is actually is not again. Then we'll proceed with this, which will output the val is either 1 or 2. So moving on, we'll discuss looping. So again, just like the void loop, it continuously runs a block of code repeatedly when condition is satisfied and unchanged. So this can go indefinitely when you code it wrong. No? So always make sure that you have an exit condition or that exit condition will be met. Then for loop, so you can use for loop is used for running a block of code for specific number of times only. So I'll show you that. While this for the while loop. So again, using the previous value, we have the val is equals to 3. So it will check whenever if val is greater than 0, then it will run all of this until that the val is not greater than 0 anymore. So here, this is actually a decrement. We decrement the val by 1. So this will run 3 times. Because it will decrement 3 times, then this condition will not be met when the val is equals to 0. Then for loop, it is created by initializing an iterator variable here. So normally we just use int I as always. Then here we have the condition and the update. So how this works is that it will check the condition, then do this update at the end of all of this block of code. So let's say here, the val is 0. No? So once they start, it will check if the I is less than 3, which it is, then it will increment val by 1. Okay, so let's say that this is I, the variable I, and this is the val. So we started the for loop. We incremented the val at saka palang ma-increment yung I. Then this goes on until that the I is equal to 3. No? When I is equals to 3, then the conditions are not met anymore, then we'll proceed to the code other below outside of this. So with that, let's create a simple program, no? So I'll demo it for you guys. So if you have proper components, then you can follow this. So we'll create a simple LED switching program using a button as an on-off switch. And we'll log in the serial the current state of the LED, meaning if it will tell you if it's on or off. So let me just change my share screen. Arduino IDE. Where are you? Yeah. Okay, can you guys see the screen? Oh no, I'm sorry.
Yes, sir.
Kita nyo naman, no?
Yes po, sir.
Okay. So again, what What are the conditions? So we'll use serial as output, use LED as an output device, and use a button as an input device. So we can start by declaring the pins that will be used. So let's say pin LED is to be used in pin number 2. Then we use the button as input. In button at let's say pin 3. So we declare the lakihan natin. Yan. So we declare again the pin mode here. Pin mode for the LED, since we're using it as an output. And Data read pin LED. If it's low, then bubuksan natin siya, no? Then di-display natin sa serial na LED is on. Okay. So here we don't need to use an else if condition para i-check kung naka-high siya or yung high condition niya. We can just use else. Kasi ano lang siya eh. If hindi siya then dalawa lang siya eh. Dalawa lang yung possible condition niya. It's either bukas siya or sarado siya. So, magpahirapan sarili, copy paste. Then, low. Off. Yan. Then, it's better if you put a delay. Kapag hindi ka naglagay ng delay here, ang possible na mangyari is magbiblink yung program mo. Because this actually runs really fast. So, multiple times naglo-loop yung code mo. So, you'll have a delay here. Kita rin natin yung mamaya. Then, we upload it. Let's code. Yan, no? Yan. We have already done uploading it. So, etong next part is I'll show you how to connect them, no? Yan. Although sorry for my camera, medyo malabo talaga siya. So here we have a breadboard. We have here the button. Then we have LED and some wires over here. Positive. So for our input, we're using again the pin. Okay nga pala yun. Forgot already. Ayun. Pin 3, 4 button. So, ito yan. No? This counts from 0 to 3. So, dito tayo sa pang-apat na butas because this accounting starts with 0. This is used for the button. Then, we connect this to ground. Then, as for our LED, always remember, ang positive sign ng LED is yung mahaba. The longer leg, which is connected sa output natin, which is on pin 2, which is yung pangatlong butas here. Then, the shorter leg goes to ground. Reset lang natin. So, theoretically, this one should work. Yes, it did. If you can see on the monitor here, it actually outputs LED is on whenever it is pressed. Let me just share that part. Zoom. Share screen. Yan. Let me just share my serial monitor. Whenever I press this, you can see that it's turning on and off. Kapag hindi tayo naglagay ng delay here, let me just show it. Ganito mangyayari sa kanya. Let me just upload the code without delay. Yan. Ayun, no? And dami kagad lumalabas dahil yung isang button press mo na yon, it runs really fast. So it detects the input again and again. So as you can see, it kind of flickers. Hence, that's why we need a delay. Okay, I'll show you naman if we didn't use input pull up. If we just use the input mode. So again, if you're not using, that happens when this happens when you have a floating state, so it's unsure whether it's high or low. Kaya ang di niya alam yung gagawin, so it's either high or low every now and then. Hence kaya nagbi-blink siya. So always be mindful of that. Balik ko lang sa input, pull up. Yan. So yan, no? Instead of using 2 buttons for on and off, you can just use 1. That's pretty efficient, no? Don't you think? Oh no, okay. Yeah. So with that, we've created a simple program using the Arduino. We created our own simple program. Kung sumunod man kayo or no. So moving on. Let me just fix my screen. Okay. Di pa tayo tapos. Okay. Yan. So we'll proceed to additional information. No? So yeah. So there are things that are called the Arduino modules. So Arduino on its own, it cannot do much until we add the sensors. So that's where the modules come in. There are ready-to-use boards. They add functionalities to the Arduino, so they can be sensors, controllers, or display. Again, as I've said earlier, there are some modules that requires greater voltage. So whenever doing that, use an external power supply or power source. And whenever you're doing that, always remember to connect the ground of those 2 different circuits, else they won't work as intended or it will misbehave. So here are some of it. Katulad ng pinakita ko kanina, we've used an IR sensor to detect if there's something blocking its path. We have a temperature sensor. We have hold this. I think this is a microphone. So for audio levels, then we have a moisture sensors. We'll answer some of the question later. Okay. Let me just finish this up in a bit. So there are also Arduino shields. So shields are pinapatong siya sa board itself. Hence mukha din siyang Arduino. Pero minsan makita mo mukha siyang Arduino pero hindi. Those are the shields. So they work the same as the modules. They can be plugged over the Arduino to expand the capabilities. So pwede siyang Wi-Fi module, pwede siyang Bluetooth or CNC shield, no? For driving, pwede kang mag-create ng 3D printer using an Arduino, as far as I know. Okay, so libraries. I've talked about this earlier. This makes coding much easier whenever you use also for different kind of modules and shields. So the Arduino environment can be extended through the use of libraries. taken is the use of existing sensors, modules, and controllers. So the Arduino community is actually quite large. So you can almost find every libraries of every available module out there. So you can easily interface your Arduino to, let's say, an LCD display, although yung simple na 16:2 LCD display, or you can use the servo motors without writing your own functions. So to access this, just go to your Arduino IDE, then under Tools, you can find Manage Libraries there. Then actually you can search for the libraries there, libraries for, let's say, the Wi-Fi module that uses ESP8266. You can just type it and it will automatically search compatible libraries. So there can be multiple libraries for the same module. So find one that works well. Yun lang. So again, alternative to Arduino boards, I actually have several Arduino boards here. Alternative Arduino boards. So over the years, they have matured a lot and the cost has greatly decreased talaga. There are clone boards everywhere and many alternatives that are compatible with the IDE. So dati, yung Arduino boards will set you back around 400 to 500 pesos, no? Clone pa yon, hindi pa yun yung original. But over the passing years, you can get this as cheap as 150 pesos, no? Although most likely those are clone boards. So we'll discuss the difference of a genuine and a clone board here. So here are some of the clone boards. Again, basically the only difference is that a genuine Arduino uses its own USB TTL MME. USB TTL, so that it is easily compatible, no, right out of the box. So you won't have the drivers that you'll be using is included in the Arduino IDE. Okay. While using a clone board, the only problem is that you'll have to download the what you call that? You'll have to download the drivers for this board. This board uses different USB TTL. So if I remember correctly, this one uses CH340. So you'll need to download that before you can actually use this. Then here is an Arduino Lilipad clone. It's quite cute. It's mostly used for wearables. So yan, ito na yung mga ibang alternatives that is not based from Atmel Atmega 328 chip. These are one of the best alternative, which is an ESP8266. It is a low-cost open-source IoT platform. So out of the box, you can connect through the internet using this. It has its own Wi-Fi module, no? So it has larger ROM than the Arduino and all around faster. This one can also be used to interface on the Arduino IDE. I'll show you some cool examples kasi madaming third-party software para dito sa ESP8266 that you can easily use for IoT device. So it's pretty neat. Wait lang. I've connected this ESP8266. Wait, let me just show it to you. Yan. So I create a simple program using the third-party app Blink to control this servo. So it has a fixed movement. No? I'm just using my phone. And this is the module itself. Sorry about that. And I can control this already over the internet. This slider is just for changing the if I want to indicate a specific angle, no, so a servo can go from 0 to 180 degrees. So this is 0. Then if we slide it all the way up here, it's 180. This one is, I just coded it in a fixed position, which is 0 and 90 degrees. You can see, no, there's some bit lag between them because, again, this is over the internet. So if you're going to make something that is where timing is crucial, like controlling things, I wouldn't recommend using this. Use a RF module or something. But if you're going to use a simple IoT device, this is really good. You can actually also send information here, and then it will go through the cloud server and show that data here, although I didn't prepare an example for that. The only downside of using the ESP8266 is that it has fewer general purpose IO ports, but really for what it's worth, it's actually really cheap, and it's really, really cool to use. I actually really like this one. So moving on, this is the STM32. It is based from a 32-bit ARM. ARM na siya, so halos same na siya sa mga core sa cellphone nyo, no? Although this one is bigger. So this one is all around faster than a typical Arduino board. It has better I/O count. As you can see, ang dami ng pin array niya in a small form factor. So parang ano na to Arduino Nano, and it also uses a micro USB. So there's that. So the advantages of this is that it has a 12-bit analog to digital conversion, the resolution, no? So you can have precise feeding here. Then it is generally faster, no? Although I wouldn't recommend it this much other than simple alternatives is the Teensy board. Actually, back in the days, mas madaming prefer itong Teensy board because first of all, they're a lot faster. Then they're smaller than Arduino board. Then some claim that they have better core and library. I cannot attest to this because I haven't actually used this one. Pero there's also a big community that uses Teensy boards. Okay, so moving on from alternative boards, miniaturizing your projects. So while you can use an Arduino Nano or Pro Micro to minimize your project, pwede yon. Except it will still cost you a lot. So miniaturizing your project again makes your project permanent. So once na ginawa mo siya, if you want to make it permanent, no, so if you want to create a permanent irrigation system or something, it is better to miniaturize your project. So it saves space by removing unnecessary components. So pwede mong tanggalin yung mga USB parts, yung mga regulator parts, then you'll be live with the Atmega chip. Katulad ng nandito, no? We only have the 328 na DIP chip. See, this too can also run as its Arduino, no? So it's actually simple to to transfer the chip into a breadboard, no? So once you transferred it to a breadboard and attest and check that it's working, then you can actually create a PCB for that. So yung mga CPE dyan na magde-design, kailangan yung gawin talaga to. So you can burn the code using, again, an FTDI module here. Something like this. Or you can just, when you have an Arduino board, just buy another Atmega 328P na dip switch, ay na dip na package. So these are actually cheap. It's you can buy like an 80 pesos of chip, but do note that it doesn't have the Arduino bootloader yet, so you'll have to burn that. There are simple guides on the internet where you can do that, but it's easier if you have two Arduino boards to do that. So I'll again show an example. So I created a simple Blink program, then move that, then I miniaturize it and put it on a breadboard. So here, you can see how small lang siya, no? So this is the chip. These are the core component, which is the crystal oscillator and some capacitors. Then 3 pieces of wire and the LED itself. Yeah. We made a simple Blink program, no? We just uploaded it to a board like so. Then we can actually remove this and put that here. You just need a flathead screw, a small flathead screw, to pry it out. There. Then you can easily take this and put this on a breadboard. It's easy, I tell you, and it's fun. So because you'll learn more about electronics. Do note that this requires 5 volts to run. You can use 3.3 volts, then use a separate regulators to run other component that requires 5 volts. Let me resume the presentation. Okay. Yeah. So, ito yung may nakita akong ito yung isa sa mga simple na Arduino versus Raspberry Pi. Sino mas angat, sino mas karapat-dapat. Oh no, it's already 4:30. So, we'll make this fast. So, Raspberry Pi and Arduino boards are different. Again, they are very different. This is a microcontroller while this is already a computer, no? So, ayun yung key difference nila. Microcontroller lang to. This is a mini computer. Microcontrollers are good for repetitive tasks, while this is when you need a full-blown computer. So, what are the advantages and disadvantages? So, actually, both have their own pros and cons. So let's start with the RPi. So pros is that it's already a computer. You just add an SD card, you add the display via HDMI, then your peripherals like keyboard and mouse, then it's already a computer. All you need is to install an operating system. So yes, then again, no, yun yung isa sa mga pros din niya. It has an operating system because it's a computer. So it's good at software applications. So it can run multiple applications at once or programs, unlike the Arduino that only runs the one program you coded it to do. And all around, it is much faster, no? Because already this is on a gigahertz level, while this is only on kilohertz, I guess. Kilohertz. So what are the cons? So first of all, it is expensive. Although it's not that much, it's not relatively expensive. No, you can buy one of these for 2,500 brand new. So for a computer that can do a lot of things, that's already cheap. But still, if you're doing a simple projects, this is still too expensive. So, and also another con is that it needs initial configuration. If you don't have SD card, then this one won't run. And if you don't have an operating system, this won't run as well. So it's more also complex to use, no? When you're a beginner, I feel that it's more daunting to learn Raspberry Pi because you'll be forced to learn Linux rather other than Python, no? So there's a lot of extra steps. So before you can have this up and running, although it is good for uh, when you can work around with this, this is you can almost do anything with this. And also it is weak against power interruption. So if biglang nagkaroon ng outage or something, there's a possibility na makokorrupt yung files mo or programs mo. It's weak against those, so it's better if it's running on a portable batteries or something. And isa pa pala na hindi ko nalagay, maarte to sa voltage. Like, may specific ano lang talaga siya rate na para tumakbo siya, while an Arduino can almost run even with dirty power na hindi regulated. So moving on to Arduino, what are the pros and cons? So first of all, and it's easy to use, no? So compared sa extra steps na gagawin mo para magamit to, this is far a lot more easier to use. So good for, again, as a microcontroller, it's good for repetitive tasks. And this is cheaper, no? If you want to make something simple, this is cheaper. This is like 10 times cheaper than an RPi. And importantly, when you buy this, is ready to use, no? Right out of the box. You can already use and create programs with this. So here are the cons for the Arduino. So again, it only runs one program over and over. So the complexity that it can do is based from what you coded it to do, no? And again, this has limited capabilities. This is not as fast as, let's say, an RPi again. And one of the problems is you don't have a debugger. So sometimes you won't know what is wrong with your project. So you'll have to snoop it out yourself. So when do you use an RPi and when do you use an Arduino? So you use RPi when you need a full-blown computer, no? And when you're required to perform multiple tasks at once, kasi again, this can only run one program at a time. This one, computer, pwede kang mag-run ng multiple application at a time. So you also use this for complex calculation and analysis. While this can do calculation, it is limited, no, from what it can do. Then this has internet connectivity. Right off the box, it has Ethernet, then it has a built-in Wi-Fi also. Although you can use an Node MCU or ESP8266 to have internet connectivity, there's only so little thing that you can do with that at most. So when do you use Arduino? Simple operations and automation, no? Creating also important in creating a control system. This is better for making quick prototypes, no? Kasi the beauty of Arduino is that you can easily create, you can design, create, then if you're done with it, you can actually recycle it again, no? So Arduino is also good for obtaining data from the environment because you can input a lot of sensors here as compared to this one. But in all, why do you need to choose between them? There are certain occasions that you can actually use an RPi and Arduino to work together. No? So let's say you want to make an automatic irrigation setup that relies on weather forecast. No? So you can program the Arduino to do the irrigation part. So what the RPi, what the Arduino can do is the irrigation part. It can obtain the data from the environment, like let's say the moisture. It can send that data over to the internet. Then over the RPi will run a server that obtains that data, no, and interprets it on what it should do. Then it can send a signal to the Arduino that hey, you should start doing the irrigation now because the certain level of the moisture is below threshold. So it will send that, and the Arduino will do its thing. Or the data interpret the RPi can also check the weather forecast to know if whether there will be rain. Then it can also send a signal to the Arduino again to say that hey, it's going to rain, so there's no need to do that irrigation stuff. So that can work. So hand in hand, you can have the best of both worlds working together, no? So with that, no, I would like to end the discussion here. No, hope you're able to pick up a thing or two in today's discussion. So you may see things as making things yung katulad na itong simple prototype to take you like what half a day to make just to automate mundane things. But no, I see it as a learning process. No, building is a learning process. Build is better understanding. Uh, Better understanding involves learning and doing. Yeah. So with that, I will end the discussion there. So I can now accept questions. No? Hello.
Yes, hello, sir. So, before we're going to entertain questions, we would like to request everyone to turn their cameras open for the picture taking first. Thank you. Again, we would like to request the attendees to turn their cameras open for our picture taking. So I think we're ready. So for the first page, 1, 2, 3, smile. Okay, for the next set, hold your smiles. 1, 2, 3, smile. Third set, 1, 2, 3, smile. Fourth set, 1, 2, 3, smile. And last set for today, 1, 2, 3, and smile. So thank you. You may turn your videos off right now. So at this point, for our for the next part of the program, we are now going to entertain questions from the attendees. So we would like to remind you that kindly wait for the acknowledgement before unmuting your mics, and you may also send your questions through the chat box. Thank you.
Okay, no, so kanina pala may nakita na kagad akong question. And I would like to answer that. Sino nga po yung tanong nun? Question from Ninbert Miguel. Possible po ba mag-connect ang Arduino sa Raspberry Pi gamit wireless transceiver module? I'm pretty much sure that it can, though I think for longer distance, it's better just to send data over the internet, no, or Wi-Fi connectivity. Just set up a server to do that. Possible po mag-connect ang Arduino.
Another question from Neil Edison Mercado from the chat box. Sir, trusted store po to buy Arduino boards.
Trusted store, actually. Kung gusto mong, if you want to buy and get that fast, you can just buy it from Shopee, no? Di ako endorser, pero you can almost buy anything there. Usually from Maker Lab, Spark Fruit, Circuit Rocks, and although hindi ako hater ng Gizmo, pero medyo expensive yung price ng e-Gizmo. Although you can still buy there. Or if you really want to go cheaper, you can buy from Shopee. Just type Arduino Uno. You can buy them from China, no, from Shenzhen. They're actually a lot cheaper. You can buy this for 150 or 125 without the cable. Although the downside, again, it doesn't have its own. You'll have to install the drivers for it, although it's not that hard.
Next question from Roel Pico. What are your recommended module for passing data from Arduino to a web page?
Module. You can use the ESP8266. It's actually a Wi-Fi module. No? There is actually a smaller one that can be paired with Arduino, the ESP8266-01. Then it uses the ESP library to connect over the internet. Or again, just buy a Node MCU or this one. This one is the Wemos D1 Mini. It's actually also cheap. You can buy this for around 150 pesos. Again, the only downside is that it has fewer pins. If you need a lot more pins, then just buy a Wi-Fi module, then connect it to a Arduino.
So the next question from Arvin Bulatin. If I want to make a project like a remote helicopter, for example, should I use Arduino or Raspberry Pi?
It's a I mean, for that, I think Arduino will be enough for that, no? Because this one is also expensive, no? So if you're trying to keep the cost down, just use Arduino. Use a RF, use RF for the controller. Then just hook this up to a series of servos and motors. If you're not obtaining any data, I think this is a lot better. And also, again, you can just add a Wi-Fi module if you want to gather data from aerial, no? Okay. Pero if remote control lang, this one is good enough. And it's a lot easier to work around with.
a question from Miko Magnaye. PIC or PIC and Arduino po ba ay same lang ang language na ginagamit?
Ang PIC, alam ko it uses a C++, so they're actually quite the same except that Arduino is a lot simpler, no? Kasi C++, mas madami ka nang pwedeng ilagay dyan. Although madami ka rin naman pwedeng ilagay dito, pero mas complex na yung coding mo or different na yung ano ba, semantics ng coding mo. Although it's also just based from C language. So if ilipat ka sa PIC, I think there's from Arduino, I think it wouldn't be that hard to transition, no?
Okay, since we are short on time, the last question will be from Nishant Ra. Can Arduino be used in industrial applications?
That's a tough question, no? Because compared to what the industry is using, they actually use a much better and faster microcontrollers other than Arduino. Although if they're small scale and they want to create a prototype, I think they can use Arduino for certain amount of things, although it is very limited. And I think the industry would prefer other things that is not Arduino, although they can use it, no? Or just creating simple prototypes. Although they can use it, though, I think it's not worth it on their side. It's not worth it because, again, there are a lot stronger alternatives to Arduino that the industry is actually using, no? Mga FPGA boards and that kind of stuff. Yeah.
So,
alam ko, wait lang. Meron nag-ano dito na if pwedeng i-upload yung slides. Yes, I can upload the slides and give the links to you, no? If you want to go around again the presentation, I'll just coordinate with the peoples in charge. Okay.